Hello, this is Miss Clifner with your video lesson for Monday. The essential question is still, how can we use multiplication or division to solve an equation? Your homework is going to be in Big Ideas Math. There's 10 problems, so let's get started with the notes. Okay, here's the warm-up. Solve each equation and check your solution. Go ahead and pause the video and try each of these problems. You see that I'm giving you a little bit of review in adding, subtracting, multiplying, and dividing. Okay, here we go. I draw the balance scale. I look at the side with the variable, and I do the opposite operation. So m is 2.2 is being subtracted from m, so the opposite is adding 2.2. So I add 2.2 to both sides, and I get 5.7 equals m. The zero pair cancels out. My check is to plug it back into the original equation, and I write this, 3.5 equals 5.7 minus 2.2. I'll let you go ahead and check it with a calculator and say, yes, this worked out. 3.5 is equal to 3.5. Check. Okay, B. Look at the side with the variable. This is a plus 4, so the opposite of adding 4 is subtracting 4. I draw the balance scale. I subtract 4 from both sides. Whatever you do to one side, do to the other. That's a zero pair. I get k equals 10. I plug it into the original equation. 4 plus 10 equals 14. I do the math on the left. 14 equals 14. There's no math to be done on the right. You just had a number 14. Okay, notice that now I have a number next to a variable, which means multiplication. The opposite of multiplying is dividing. I draw the balance scale. I divide both sides of the equation by 5. Remember, it's going to cancel out with that giant 1, and I get y equals, again, use a calculator, 0.7. I check my work by writing this. 5 times 0.7 equals 3.5. Remember, I'm taking this value and I'm plugging it into the original equation. And then, yes, 3.5 equals 3.5. Check. All right, the last one. This is a division problem, right? You see a fraction bar. I'm taking some number and I'm dividing it by 5. I want to do the opposite, which is to multiply by 5. So I draw my balance scale. I put it times 5 over 1 because this side has a fraction. Over here, I just put it times 5 because there is no fraction. 9 times 5 is 45. These 5's cancel out in a giant 1. 45 is equal to V. There's my solution. When I check it, I do this. 9 equals. I plug the 45 in for the V. 45 divided by 5. 9 equals 9. Check. Okay, the more you practice, the better you get at those. Okay, so now we're going to look at something a little bit different. Let's say the mystery bag is only 2/3 full of gold and it has a value of 16. How much gold would the bag contain if it was completely full? So first of all, I want you to think about the equation that you're seeing in the picture. So they're basically saying it's 2/3 of a bag. So remember, of means times in math. So the equation that you come up with is 2/3 of x has to be equal to 16. Okay, so now I want to show you, it's not a little math magic, but the idea is I can change this equation in some different ways so that that you see it's actually a two-step equation. So here's what I want you to see. That really, there's a little tiny dot between these, right? And then really, if I'm multiplying 2/3 times x, doesn't it make sense to put x over 1? So all I'm doing now is doing what I told you not to do, right? Usually I say put the number and the variable next to each other. Well, what if I separate them with a dot, right? And then I put a 1 underneath the x. So now I've got something that looks like this, right? So here's my equation. And then remember, when I multiply across, I take the numerators and I multiply those, and I take the denominators and I multiply those. I'm not doing anything with the 16 side. I'm just trying to rearrange the fractions. So then I have something that looks like this. So notice I started out with 2/3 times x, and now it's kind of interesting because it looks like 2x divided by 3, which means the same exact thing. But what did I do to get from the first equation to the second equation, right? All I did was separate the multiplication and put the dot back in, and I put the x over 1. And then from the second to the third, I did the multiply across. So now I've got an equation that we're going to do some kind of fun math with. Okay, so here's my equation. And first, I want to undo the division, right? So there's two things happening here. It is 2x divided by 3. So I've got the divided by 3. So I asked myself, and I'm just going to type this in. What is the opposite of dividing by 3? Question mark, right? What's the opposite of dividing by 3? Well, it's going to be multiplying by 3. So I'm going to multiply both sides of the equation by 3. And I put a little dot here, and I multiplied this side by 3 over 1. And I multiply this side by just 3, right? Because I've got a whole number. There's no need to complicate it. And then you can see the 3's are going to cancel out. My giant 1. I'm dividing the numerator and the denominator by 3, which leaves me with 2x over 1, which is just 2x, which is what I got in the box below. And then 16 times 3 is 48. So we did the math, and we're bringing it down. Now I'm going to undo the multiplication. And so now I'm asking you to look at the equation and say, what is the opposite of multiplying by 2? Right? So now, so the first thing we did was we multiplied by 3 because this is division. Now we're going to be dividing by 2 because we have multiplication. So this is generally called a two-step equation just because there's two things to undo. So I'm going to draw my balance scale, and I'm going to divide both sides of the equation by 2, right? Because I always look at the side with the variable, and I'm undoing it. 2 divided by 2 is just 1. That leaves me with x equals 24. So we just had an interesting way to solve an equation using two steps. Now I want to show you the same thing. Well, what if we didn't change the equation, right? We changed it so that it was 2x divided by 3 equals 16. What if we go back to the 2/3 x? So remember, there's this thing called a refliprical, and that's when you flip a fraction upside down. And a really cool thing happens when you multiply a refliprical times the number that you started with. So it's like this. So if I take 2/3 and I multiply by 3/2, what does it equal? Well, if I multiply across, I would get 6 over 6. Wait a minute, that just equals a giant 1. So, cool thing happened. You know how when I'm solving an equation, I like to get my variable by itself with a phantom 1? I create a phantom 1 by multiplying by the refliprical. So I want to retry this equation, but we're going to multiply by refliprical, and it's going to be one step. So here's what I got. Okay, let me move me there. All right, so I put the equation was 2/3 x, and this time I put times 3/2 because that's the refliprical, right? When you look at 2/3, the refliprical is the fraction upside down 3/2. So I put 3/2 already over here on the left, but then guess what? On the right, this is a whole number, but I'm going to have to put it over 1 because now I'm going to be multiplying the right side, right? Whatever you do to the left side, you do to the right side. So I'm multiplying by the refliprical on the left. I have to multiply by the refliprical on the right. We already know the answer is 24 because we just solved it using two steps, but now I'm trying to do it using one. Okay, so the 2 numerator and denominator, that cancels out. There's a giant 1. 3 and the 3 numerator and denominator cancels out, giant 1. I'm left with x equals. Okay, I'm going to divide by 2 and divide by 2. The numerator and denominator had common factors. This is a 1. This is the 8. 8 times 3, 24. Okay, so cool. So now you get to decide if you see an equation like this, do you want to do it in one step or do you want to do it in two? It's going to be totally up to you. Okay, so here's our key idea. We can solve equations that involve multiplication of fractions by using the multiplicative inverse property. Pretty fancy. It says if you flip a fraction upside down and multiply by the inverse number, that the product equals 1. So, and it has to be a non-zero number because you guys know, we've talked about this, you can't have 0 in the denominator, you can't divide by 0. So your number has to start out with not being 0, and it results in a value of 1. Okay, so here's our example. We have 2/5 m equals 8. And I look at the side with the variable and I want to undo the math, and I kind of say the opposite of multiplying normally is dividing, but this time I'm going to say the opposite of multiplying by 2/5 is multiplying by the reciprocal. So I'm going to multiply by 5/2. And if I multiply the left side, I must multiply the right side to keep my scale balanced. And then the 5's cancel out as a giant 1. The 2's cancel out as a giant 1. Over here, I could multiply across, but I want to start simplifying before I multiply. 2 goes into 2 once, 2 goes into 8 4 times. So I get 20. Now let's do a quick check. So it's a little more complicated to do a check when we have fractions, but we can handle it. Okay, so here's my check. I'm pretty sure that my answer is, let's write that better, m equals 20. Now we're going to check it by plugging it into the original equation. The original equation is 2/5 times m, but instead of m, I'm putting in 20. And because 2/5 is a fraction, I want to put my 20 over 1, and I'm going to see equals 8. And then I'm going to do some simplifying. 5 and 20 are both divisible by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. And when I multiply across, I get 2 times 4 is 8, and 1 times 1 on the bottom. 8 over 1, definitely equal to 8. Okay, now I've got an OYO for you. So try this one. It's 2/3 y equals 21. You're going to solve it. You're going to check it. Look at the side with the variable. Multiply by the reciprocal. This cancels out as a giant 1. I'm left with y equals, this is going to be a decimal. Oh, let's see, because 2 does not go into 21. So when I multiply across, I get 63 halves. And then you can use a calculator. I know I need to add a decimal and it goes to 0. 2 goes into 6 3 times. 2 goes into 3 once. 31.5. Oops, I put that in the place of my check. Okay. Y equals 31.5. Let's check it. So I put in, and this is where I'm going to want to use this improper fraction in my check to make my life easier. Don't use the decimal. Or you can, but I'm going to put in the fraction. So I have 2/3 times the y, but instead of y, I'm going to plug in this number, right? Plugging that in. 63 2 equals 21. Okay, so the 2 and the 2 cancel out, and then, I could just multiply across and say this is 63 over 3, right? 1 times 63 and 3 times 1, and then I could use a calculator and check it. I know 3 goes into 63 21 times. 21 equals 21. Wahoo! Okay, one last thing to show you. You might see problems like this in the textbook. So it says convert each of the following 2-step equations into a 1-step equation. So I want you to think about this. When I have 2x divided by 5, I can just turn it into the, I can look at 2x divided by 5 like that equals 16. And then remember, I can look at the 2/5 as a coefficient, and I can put it in the front like that. Now you could still do a one step even if you write it like this, but the idea is I'm trying to get you to see that you can be flexible with how you group your numbers and move fractions around. If you think about the numerators and the denominators. So this one would be 4m divided by 3, which I want to change to 4/3 times m, right? So I'm just rewriting the fraction and basically pulling it away from the variable so that now it's a coefficient. What? 28 equals 7y divided by 12, but I want to make the 7 and the 12 a fractional coefficient like this. 28 equals 7/12y. Okay, cool. So your homework is Big Ideas Math, and it's online. Good luck.